All right, now we'll begin the second part. We'll pick up where we left off with domain and range of graphs. So we'll be looking at a little bit more involved problems. So here's our first example we'll look at. So we'll first do the domain. Just like the previous ones, domain is left to right. So it looks like this goes as far as this arrow. But now this arrow, because it's continuing to point to the left, that means eventually it will get to negative infinity. So it's a little different than the previous ones where there was an end point. So this arrow says keep going forever. To the right, it goes as far right as this 8. So it looks like we got this interval from negative infinity all the way to positive 8. So let's write this as an inequality. So when I look at this part at the 8, notice what I don't see. I don't see an open circle. So that means we are actually including the 8. So when we write it as an inequality, it looks like we want everything smaller than or equal to 8. But again, there was no need to put this in the negative infinity in the inequality because the entire picture starts at the 8 and moves forever to the left. So x is everything smaller than or equal to 8. Now let's put it in set notation. As you saw previously, you just pick up where you left off with the inequality. The domain is a set of all x's such that x is less than or equal to 8. I'll say it again. The domain is the set of all x's such that x is less than or equal to 8. And then in interval notation. Now, interval will come straight from there. The open parentheses negative 8, open parentheses negative infinity, comma 8, close parentheses. So there's our domain. So what's different here is having where it ends with an arrow to recognize that continues forever. So let's look at the range of that same picture. So from down to up. So this goes as far down as 0, not 8. 8 is to the right. So I'm going down, down. It goes as far down as 0. And it goes as far up as the arrow. So now this arrow continues to go up, up. So we're not going to negative infinity, we're going to positive infinity because we're moving down to up as opposed to the domain, we were going to the left when we hit that arrow. Here again, we're going on an upward mobility and we hit the arrow that says you would continue to move up positive infinity. So we're within this range here. So it looks like from 0 all the way up to positive infinity. Again, I'm emphasizing I'm going down to up, not up and down to up. So let's write it as an inequality. So when we notice here, it goes as far down as this point, and this point is not an open circle. So it's a closed circle, so we are including not the 8, but the 0, because the numbers we're using are 0 and infinity. So there's our inequality. Y, again, because it's the range, we're using Y. Y goes from 0, and we're included, all the way up to positive infinity. And notice, of course, we don't put an equal for the infinity. Set notation, just pick up where we left off. Again, the set is now the range, and the variables we're using are y's. The most common error is to consistently use x's for everything. So be careful. And interval notation, just going from the 0 to the positive infinity. 0 is going to have the bracket. Infinity has the parentheses. So that was a little different type of situation. Let's look at the next example. All right, even a little bit more different. So let's first look at the domain. Domain again goes as far left, far right. Looks like this thing initially goes as far left as the arrow. And again, because I'm going left, that's negative infinity. And when I go to the right, it also hits the arrow. This one is going to the right, so that's positive infinity. So initially, it looks like we have the entire graph from negative infinity to positive infinity. However, there's something going on right here. It looks as if that when we get to this -1, the graph never actually gets to -1. It's kind of skipping it. What we have here, this dotted line, is called an asymptote. Asymptote. Asymptote, an asymptote. What an asymptote is, it's an imaginary line, so it's not part of the graph. The asymptote here is this blue dotted line. It's not the black graph. And what it is, it's an imaginary line that the graph gets closer and closer and closer, but never actually comes in contact. So you can see here, the black graph gets closer and closer and closer to that blue dotted line, where down here, it gets closer and closer and closer to the blue dotted line. So really, we have to consider the domain is not everything, but it's essentially everything except that -1. So it looks like the domain has to be broken into two parts. So we're looking at from negative infinity to -1, and then from -1 to positive infinity. So this domain is broken up into two parts because the asymptote kind of breaks it up. It says, hey, you can move this whole thing, but you just can't be at -1. So let's write this sucker as an inequality. So the only thing we need to be careful of is the -1. Because you can't be there, it will not be a closed circle, so we cannot equal it. So the inequality will not have an equal sign with the -1. So we're going to create two separate inequalities. First inequality is x is less than -1. That's this orange region over here. And then the second inequality is x is greater than -1, which is this bluish region over here. And now to show the entire inequality, I simply put the or in between. So this entire line is the inequality. So it's saying x can be anything over here, or it can be anything over here. If we look at it in set notation, it's going to be the exact same thing as inequality, but now we're using the braces. Now I have it a little bit differently. Here's what this says. The set domain is the set of all x's such that x is an element of all real numbers. However, x cannot equal -1. So this is a fancy way of simply saying every number except 1. Again, the little element symbol, and that's the symbol for all real numbers. So it says x is every number except -1. Again, don't let it confuse you. It's just a different way of writing it. Last, interval notation. So in interval notation, I'm just going to show these two separate inequalities. So there's my negative infinity to -1, which is this inequality here, and my -1 to infinity, which is this inequality here, and I'm putting the union symbol. The union symbol kind of sort of is what was happening with the or. All right, so let's look at the range for the same picture. So we're going down and up again. So there's down, it goes as far down as this arrow. And because I'm going down, that's going toward negative infinity. Same thing going up, goes all the way up to this arrow, which is positive infinity. So, looks like we have this entire graph. But just like before, there's something going on here at the 1/2. So again, like the domain, we have another asymptote. So this says we can have everything except that 1/2. So if we go bottom up, from bottom up, as you can see, there's the asymptote. The picture is getting closer and closer and closer to here. and it's getting closer and closer there. So we're breaking up into two sections like I had before. So I can go from negative infinity to 1/2 and 1/2 to positive infinity. So we got two regions. So the inequality, there's our y is less than a half. That's the blue. And y is greater than a half. That's this grayish region. And we simply put the word or in between. There's our inequality. Set notation, same thing as I did before, shows that y is all the elements of the real number set, but you can't have 1/2. That's basically what it says. Every number except a half. And then finally, interval notation. We'll do the same thing we had here with the union. So there's the blue from negative infinity to 1/2. Notice there's the parentheses, and 1/2 to infinity. I think I have one more example. All right. So here we go. Domain. Let's see how far left this thing goes. Looks like the arrow, negative infinity. How far right? Looks like the arrow, positive infinity. However, there's some things going on. So it looks like we have the whole thing. However, looks like here we've got two asymptotes. One at -3, one at +1. Those are my two asymptotes. So we're going ahead and consider we have a few regions to consider. The first one, again, we can see this is an asymptote because right here is getting closer and closer. Here it's getting closer and closer to that -3. Now here it's getting close to that 1, and here it's getting close to the 1. There's our asymptote. So our first region from negative infinity to -3, there's our yellow, then from -3 to 1, and then from 1 to infinity. So let's go ahead and consider the inequality. And because all of these asymptotes you cannot equal, that's why we have no equal sign here. So there's the yellow, everything less than -3. And now this middle section will be a compound inequality. So it's everything from -3 to 1. And then the blue region, all of the values greater than 1. Simply put the word or in between. There's our inequality. So it's kind of long, but one step at a time. And so now set notation is the exact same thing. It's a set of all real numbers. Now it's just showing, these are the two values you can't have. All right, every number except -3 and 1. That's basically what it says. And then interval notation, there's our three different intervals. Again, everything has parentheses, and there's our union. There's the first set, the second set, and the third. Now let's work with the range. All right, so we're going down. It goes as far down as the arrows, negative infinity. It's like it goes as far up. Like, hold on, it's like it stops right here first. So we're going to stop it at the 0. But we still got some more. So let's consider the top portion. So we got this bottom portion here. So let's look here. Like, it goes as far down as 1, and it goes as far up as the arrow, which is positive infinity. So we have a second region. So this entire graph looks like this has a break in the graph. So our first, we're here now, right here. That's our asymptote. Now the asymptote at 0. So at the bottom section here, it goes as far down as negative infinity, but it goes as far up as 0, but never actually touches the 0 because it's another asymptote. So it goes up as far as that, as far as the 0. There's our asymptote. So the bottom region from negative infinity to 0, top region 1 to infinity. If we look at the inequality, we will include that 1. So there's the bottom, there's the top, put the or. Set notation, same thing, exact same thing. And then interval notation, using our parentheses and brackets. Nope, everything is just parentheses. There we go.